Okay, so this is the review for test number 5. So the first one says for each rational function, find the vertical asymptote, the holes, horizontal asymptote, x-intercept, y-intercept, and other points in order to graph. Remember, we are doing this without a calculator. All right, so let me write down the first one. All right, so we have f of x. All right, so we have f of x equals 3 over x minus 2. So I notice that there's nothing to reduce. There's nothing that's going to factor. So that means there's no holes. So you could put holes does not exist. All right, let's go to vertical asymptote. Remember, that's when the denominator equals 0. So x minus 2 equals 0. Add 2, we get x equals 2. Horizontal asymptote, that's when we compare the numerator with the denominator. Now, there is no x in the numerator, so it's x to the 0 and x to the first. So notice that the denominator has a larger exponent than the numerator. That means the denominator is growing faster. So if the denominator is growing faster than the numerator, that means my numbers are getting very small. They're getting tiny. So if they're getting small, that means it's getting closer to 0. So it's y equals 0. Your x-intercept is when y is equal to 0. So set y equals 0. 0 equals 3 over x minus 2. Cross multiply. 0 equals 3. That doesn't make sense. So that means there's no x-intercept. Does not exist. Y-intercept. That's when x is equal to 0. So y equals 3 over 0 minus 2. Which is 3 over negative 2. So it's 0, comma, negative 1.5. Right, 3 over 2 is 1.5. So negative 1.5. Okay, so now we can start graphing a little bit here. And I'll have to get my table of values still. All right, but I'm going to start graphing. So I have here, let's go 1. Here's 2. I'm sorry. I'll put 4 here. Actually, let me redo this. I'm sorry, just going to redo these axes here. All right, so we have 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. 1, 2, 3, negative 4. 1, 2, 3. All right, so let's draw a vertical asymptote as x equals 2. So here's the vertical asymptote. Let's do our horizontal asymptote is at y equals 0, so that means that's right on the x-axis here. All right, let's graph the x-intercept. There is no x-intercept. And then we have a y-intercept of 0, negative 1.5, so that's about here. All right, so now I need to make my table of values. All right, so 3 over x minus 2. So I want to do, I definitely want to do these 2 points over here because I have nothing going on the right side of the vertical asymptote. So I definitely need 3, 4 in my table of values. I definitely want to put 1 in here because I have that in between 0 and the vertical asymptote. So I definitely want to put 1 in there. I don't need 0, and I'm going to put in a negative 1. All right, so let's plug into the equation. So it's 3 over 3 minus 2. So that's 3 over 1, so that's 3. 3 over 4 minus 2, so that's 3 over 2. 3 over 2 is 1.5. 3 over 1 minus 2, so that's 3 over negative 1, so that's negative 3. And 3 over negative 1 minus 2 is 3 over negative 3, so that's negative 1. So let's plot those points. All right, so I have 3, 3. 4 is 1.5. So you could see it's coming down here. So it's going to come down. Sorry, I went a little off the graph here. So just make sure you put your arrow, and there should be an arrow up there. And then we have 1 is -3. So you could see it's coming down towards the asymptote. And -1 is -1. So it's coming around like, not like that. I did not like that graph there. So it's coming around here like this. Make sure you go through your points, put your arrow. Make sure you don't hit your intercepts, okay? All right, next one. Okay, so 1b is, we have f of x is equal to x squared plus 2x over x squared minus 4. So I notice right away that I can factor the numerator and factor the denominator. So in the numerator, the GCF is x, so I have x times x plus 2. In the denominator, I have dots, so it's x plus 2, x minus 2. All right, so I notice that I can reduce the x plus 2 and the x minus 2. So that means there's a hole. Remember, it's the opposite of this, right? X is equal to -2. So now rewrite your function, the cleaned up version. Remember, that's what I call this. So remember, I have x over x minus 2. You can use this for everything else now. All right, now, for the hole, you have to get the y value, so we know where to plot this, right? Because I know my x is -2, I have to get my y value. So you're going to plug in -2 for x, so it's f of -2. So it's -2 over -2 minus 2, which is -2 over -4, which is positive 1/2. So you could put 0.5 if you want. Okay, so there's my hole at 0.5. My vertical asymptote, remember, I'm using my cleaned up version. The denominator is x minus 2, set it equal to 0. X equals 2 is my vertical asymptote. My horizontal asymptote, I have an x in the numerator and an x in the denominator. Notice they're both to the first power. So it's the ratio of the coefficients. So what coefficients are in front of the x's, right? I have a 1 in front of this x and a 1 in front of this x. So think about these, they reduce out. So I'm left with 1 over 1. So it's y equals 1. The x-intercept is when y equals 0. So set y equal to 0. Remember, cleaned up version. 0 equals x over x minus 2. Cross multiply, x equals 0. So my x-intercept is 0, 0. Remember, intercepts are written as points. I'm just going to move this up. Now my y-intercept, remember the y-intercept is when x equals 0. So I have y equals 0 over 0 minus 2. So that's y over 0. So that's also 0, 0, which makes sense because that's the origin. If it's an x-intercept, it has to be a y-intercept. All right, so let's start graphing. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 3, 4. Okay, so let's start with the hole. The hole is at -2, comma, a half. So let me bring that down a little bit. Okay, can't bring it down, so it has to stay there. All right, let's do our vertical asymptote is at x equals 2. And our horizontal asymptote is at y equals 1. So it should be right above the hole. Okay? And then we have an x and y intercept at the same place, 0, 0. All right, so now let's make our table of values. So remember, cleaned up version, x over x minus 2. All right, so let's see. I definitely need to pick 3 and 4 over here on this side because there's nothing going on over here. I definitely want to pick 1, and I'm going to pick -1. All right, so let's see. I'm going to put in 3, 4, 1, -1. All right, so plug in 3. So it's 3 over 3 minus 2. So that's 3 over 1, so that's 3. 3 over 4 minus 2, so that's 3 over 2, so that's 1.5. 1 over 1 minus 2, so that's 1 over -1, so that's -1. -1 over -1 minus 2, so that's going to be -1 over -3, so that's positive 1/3. So that's like 0.3 repeating, right? All right, so let's plot our points. I'm going to put them in purple here. So I have 3, 3. 4 is 1.5. So it's going to come down like this. And just put arrows. Just go a little bit past the dots and put arrows. All right, 1 is -1. And -1 is 0.3 repeating. So it's like this. So it's going to come down like this. Remember, when you jump over the hole, don't go through the hole. Just go a little bit past it and put your arrow. Okay, so let's take a look at number 2. Okay, so number 2, where is still a no calculator, we're graphing. F of x equals x times x minus 2 squared times x plus 5 times x plus 2. All right, so the first thing you want to do is find the zeros. So set your function equal to 0. Make your t-charts. Find all the zeros. All right, so for x, I have x equals 0. X minus 2 squared is x equals 2. X plus 5 is x equals -5. And x plus 2, x is equal to -2. Now I want the multiplicity. So for x equals 0, the exponent is a 1, so it's odd, and odd crosses. X equals 2, the factor is x minus 2, the exponent is even, because it's a 2, so it's tangent. X equals -5 is odd, so it crosses, because the exponent is a 1. And x equals -2 is also odd, the multiplicity, and that crosses. Okay, now, also in order to graph, we have to have the degree. So just add up the exponents. We have 1, 2, 3, 4, 5. So that means it's going to go in different directions. These are the choices. So now I need my leading coefficient, which is going to be +1. So that means it'll be this one here, not this one. Okay, so let's start graphing this. So I have -5. -2, 2, and 0. So plot your zeros. So I have a 0 here, 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 and here. It's going to be down here and up here. All right, so I'm going to cross everywhere except at +2. It's going to be tangent. All right, so it's going to come up from the bottom, cross, 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 and then be tangent and come up. All right, the last thing I need is the end behavior. As x goes to -infinity, f of x goes to -infinity. This is your end behavior. As x goes to infinity, f of x goes to +infinity. All right, so let's take a look at 2b. All right, 2b is f of x equals, so I notice I'm going to have to factor this. I have -x cubed plus 4x. It's in a semi-factored form. X squared plus x minus 6. All right, so for the first parentheses here, I'm going to factor out -x. And then I get x squared minus 4. And then I get -x times x plus 2, x minus 2, because I have dots. And then this factors and becomes x plus 3 and x minus 2. All right, I'm going to find my zeros. I'm going to rewrite this. So it's a -x times x plus 2 times x minus 2 squared, because I have 2 of them, and x plus 3. All right, so my zeros are x equals 0, x equals negative 2, x equals 2, and x equals negative 3. So my multiplicity here is odd, it crosses. Multiplicity here is odd, crosses. Multiplicity here is even, tangent. Multiplicity here is odd, crosses. The degree is 1, 2, 3, 4, 5 again. So that means we're going in different directions. The leading coefficient is a negative, so it's going to have a negative slope, so it'll look like this guy here. All right, so let's draw a picture here. So I have a 0, I have positive 2, negative 2, and I have negative 3 here. Plot your zeros. 0, 0, 0, 0. I'm crossing every place, but at 2 it's going to be tangent. But notice I'm coming from the top here. So I'm going to cross, 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 and tangent. And just do the end behavior as x goes to negative infinity. F of x goes to positive infinity. As x goes to infinity, f of x goes to negative infinity. All right, let's take a look at number 3. Okay, so number 3 is a composition. All right, so we have this composition here. I have my 2 functions. I have f of x here and g of x, and I'm looking for f of g of 5. So first I start with g of 5. So I go to my g function. Wherever I see an x, I'm going to plug in 5. So it's 5 squared plus 2 times 5 minus 1. So g of 5 is equal to 34. Now I'm going to do f of 34 because that's what this is equal to. So which means go to my f function. Wherever I see an x, I'm going to plug in 34. So 3 times 34 plus 6 is equal to 108. So f of g of 5 is equal to 108. Sorry, that was 108. 108. All right, 3b. All right, so 3b is g of f of x. So no numbers. All right, so it's going to be g of, now replace this with what it's equal to. F of x is equal to 3x plus 6, which means to go to my g function, wherever I see an x, I'm going to input 3x plus 6. I'm just going to go down here. So input 3x plus 6, 3x plus 6, because now it says to square this, right? It says to square your x, plus 2 times your x, which is 3x plus 6, minus 1. All right, so now I need to do 3x plus 6 times 3x plus 6. So I'm going to double distribute. So I get 9x squared plus 18x plus 18x plus 36. I'm going to distribute the 2, so I get 6x plus 12, and then I have minus 1. So now I'm just going to clean this up. So I get 9x squared, 18x plus 18x is 36x, plus 6x is 42x, and then 36 plus 12 is 48, minus 1 is 47. So this would be my final answer. All right, let's take a look at 4. All right, so number 4 is to factor. So I notice I have only 2 terms. I don't see a GCF, and I don't have, it's not dots because I have an x to the 3rd power. So it must be SOAP. So remember SOAP, same, opposite, always positive. Small parentheses, large parentheses. Same sign, opposite sign, always positive. Now remember, it's a squared, b squared, and in the middle is a times b. So a is the cube root of x to the 3rd, which is x. B is the cube root of 64, which is 4. So it's going to be x minus 4, x squared plus 4x, because it's 4 times x, oops. And then at the end, it's 4 squared, it's b squared. And 4 squared is 16. All right, so let's take a look at B. B is 2x cubed plus 16. So I notice there's a GCF. The GCF is 2. So I factor out the 2. Now I have x cubed plus 8. Again, we have dots. So we're going to do so. Small parentheses, large parentheses. Same sign, opposite sign, always positive. A is equal to the cube root of x to the third, which is x. B is the cube root of 8, which is 2. So it's going to be x plus 2, x squared minus 2x plus 4, because 2 squared is 4. All right, let's take a look at number 5. Okay, so number 5 is finding the domain and the range from the graph. All right, so 5a, remember, domain are your x values. How far to the left does it go? How far to the right does it go? Now I notice that over here it just keeps going to the left. So the domain is from negative infinity. Now as my graph comes to the right, I have like this stop here, right? I have to skip over this point, and that's at negative 3. So it's negative infinity to negative 3, and then it keeps going. Right, so it's going to be union negative 3 to positive 2, and then positive 2 has a hole, so it's going to be a parentheses. The range, which is up and down, how far down does it go to how far up does it go? So it goes down to 2, negative 2, sorry, and it includes that. Even though this is a hole here, it still includes it because I have this part of the graph here. And then how far up does it go? Well, it just keeps going up to infinity, so it goes up to positive infinity. All right, B. So it doesn't go past, for the domain, it doesn't go past 1, and it's also not including 1 because there's a hole. So it's 1, and then it just keeps going to the right, 1 to infinity. The range, how far down does it go to how far up? It just keeps going down to negative infinity, right? Keeps going down. Now, it goes up, but it does not include 2 here because there's a hole there. So it has to be 2, and then union, it picks back up on the other side of 2 and goes to positive infinity. All right, so let's take a look at number 6. Okay, so number 6 is the piecewise function. Okay, so for the piecewise function here, I notice that I have f of x is equal to 3x plus 4 when your x values are less than negative 1. And f of x is equal to x squared plus 5x minus 2 when x is greater than or equal to negative 1. So I just want to evaluate all these. I just have to make sure that I'm looking at my x values and make sure I look over here at these inequalities to make sure I know which one to plug it into. All right, so for the first one, f of negative 1, right, I have negative 1. So I don't want to use this one because this says it has to be less than negative 1. I want to use this one because it says greater than or equal to negative 1. So I'm going to plug it into the bottom one. Negative 1 squared plus 5 times negative 1 minus 2. All right, so f of negative 1 is equal to negative 6. Just plug it into your calculator. All right, next one. F of negative 3. All right, so negative 3 is less than negative 1, so I'm going to plug it into the top one. So it's 3 times negative 3 minus plus 4, sorry. So f of negative 3 is equal to negative 5. F of 0 here. So 0 is greater than negative 1, so I have to plug it into the bottom one. So it's 0 squared plus 5 times 0 minus 2. So f of 0 is equal to negative 2. And then the last one, f of 2. So 2 is greater than negative 1. So I'm going to plug it into the bottom one. So it'll be 2 squared plus 5 times 2 minus 2. And f of 2 is equal to 12. All right, let's take a look at 7. So 7 says here to put the function in vertex form and identify the vertex. All right, so let me minimize this here. All right, so we have f of x is equal to x squared minus 8x plus 10. All right, so remember, we're going to complete the square. My leading coefficient is a 1. That's what I want. Minus the constant over. So we have f of x minus 10 equals x squared minus 8x. All right, so remember, now I do half of negative 8, which is negative 4. Squared is 16. Add that to both sides. All right, on the left side, I have f of x plus 6 equals, now I get my parentheses squared, x minus 4 squared. Minus the 6 back over, so we get f of x is equal to x minus 4 squared minus 6. The vertex, remember, it's opposite of this, so it's positive 4, and this stays the same, negative 6. So it's 4, negative 6. All right, let's take a look at B. All right, so B is f of x equals negative 2x squared plus 6x squared plus 6x plus 3. All right, so first thing I notice, I have to divide everything by negative 2 because I need a leading coefficient of positive 1. All right, so I have f of x over negative 2 equals x squared minus 3x minus 3 over 2. Okay, so now I'm going to move the constant over. So I'm going to add 3 over 2 to both sides. So it's f of x over negative 2 plus 3 over 2 equals x squared minus 3x. Half of negative 3 is negative 3 over 2 squared is 9 over 4. Add that to both sides. F of x over negative 2 plus 3 over 2 plus 9 fourths equals x squared minus 3x plus 9 fourths. All right, so now we're going to clean up the left side. So I have f of x over negative 2. And then we have 3 halves plus 9 fourths is positive 15 fourths equals, and then we factor, get our parentheses squared. So remember, it's the number that you square, so it's negative 3 over 2 squared. Minus the 15 over 4 back over. F of x over 2 equals x minus 3 over 2 squared minus 15 over 4. Now we have to get rid of the negative 2, so multiply both sides by negative 2. So I get f of x equals negative, so remember this goes in the front here, 2 times x minus 3 over 2 squared, multiply there, plus 15 over 2. So my vertex is going to be 3 over 2, comma 15 over 2. All right, so let's take a look at 8. Okay, so number 8 says to find the domain. So remember I said that sometimes it's easy to think about what you can't have, and then that'll help get you to what you can have. So you have a square root. Think about what you can't have when you have a square root. You can't have a negative under the square root symbol because then it's imaginary. So then that means that 7 minus x, in order for it to be a positive number, has to be greater than 0. Now, can it be 0? Yes, you can have the square root of 0. The square root of 0 is 0. So at minus 7, so negative x is greater than or equal to negative 7. Divide by negative 1, remember flip the sign, you get 7. So x is from negative infinity to positive 7. All right, and then we have this one here. F of x is equal to 1 over the square root 2x minus 3. So the difference between these two is that one's a fraction and one's not. So your 2x minus 3 still has to be greater than 0, otherwise imaginary. But it cannot be equal to 0 because then you'll have a 0 in the denominator, and you can't have that. So it's just greater than 0. So add 3, divide by 2. So your x's have to be greater than 3 halves. So it's 3 halves to infinity. All right, next, number 9. Number 9 is you have to write the equation given the roots of your polynomial. So I have 0 and plus minus 4i. So those are my x's. X equals 0. Remember, those are my zeros. And x equals positive negative 4i. So remember, this means that there's a GCF. The GCF is x. That's my factor. This one over here, I'm going to square both sides to get rid of the I. So I get x squared equals 16i squared. I squared, remember, is negative 1, so it's negative 16. And then add the 16 over. Now I have to take my GCF, x, and multiply it by my other factor, x squared plus 16. So we get x cubed plus 16x equals 0, or you can equal it to f of x. I would take either one as an answer. All right, let's take a look at B. So B is negative 1, 2 plus 3i. All right, so one of my zeros is x equals negative 1. My factor is x plus 1. This one over here, so now remember, I have an I. Just like if you had a radical, you do have to write it as plus minus. X equals plus minus 2 plus minus 3i. Minus the 2 over. Now, to get rid of the I, we can square both sides. So we're going to do x minus 2 squared. So that's x squared minus 4x plus 4 equals 3i squared is 9i squared, which is negative 9. And add the 9 over, we get x squared minus 4x plus 13 equals 0. Now I have to multiply that by x plus 1. By my factor, my other factor. All right, so 1 times 13 is positive 13. 1 times negative 4x is negative 4x. And 1 times x squared is x squared. X times 13 is 13x. X times negative 4x is negative 4x squared. X times x squared is x to the third. All right, so we have x to the third minus 3x squared plus 9x plus 13. And make sure you equal it to 0 or you equal it to f of x. All right, let's take a look at that was number 9. So let's take a look at number 10. Okay, so number 10 says, use the graph and the remainder theorem to determine 2 zeros of the function. Use synthetic division to break down the polynomial further. Determine all zeros in simplest form. List all the linear factors. Okay, so I graphed this in the calculator, and I'm looking to see where it possibly crosses the x-axis. But however, first I forgot we have to list all possible rational zeros, right? Possible rational zeros. I forgot about that. All right, so it's the factors of 72. And my leading coefficient is 1, so it's just the factors of 72. So it's plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 8, plus minus 9, plus minus 12, plus minus 18, plus minus 24, plus minus 36, and plus minus 72. All right, so we graph it now. We graph it, and then we look to see where it could possibly cross the x-axis, and it looks like that maybe f at x equals negative 3. So I'm going to do f of negative 3. I plug it in, so it's negative 3 to the fourth minus 3 times negative 3 to the third minus 4 times negative 3 squared plus 18 times negative 3 minus 72. Plug that in the calculator all at one time, and yes, I get 0. So x equals negative 3 is 0. That means my factor is x plus 3. All right, so now I'm going to use synthetic division to break down the polynomial a little bit. So I have 1, negative 3, negative 4, 18, 7, negative 72. All right, so I have 1, negative 3, negative 6, positive 18, we get 14. 14 times negative 3 is negative 42. 18 minus 42 is negative 24. Times negative 3 is positive 72, and I get my remainder is 0. So remember, this is my remainder, constant x squared, x to the third. So I'm still not down to an x to the second power. Remember, that's what I want. I want an x to the second power. So I need to look again to see where else this could possibly cross the x-axis. And it looks like at 4. So I'll plug in 4. Let's see if we get 0. So it's 4 to the fourth minus 3 times 4 cubed minus 4 times 4 squared plus 18 times 4 minus 72. All right, and then we plug it in a calculator, and yes, I get 0. So x equals 4 is a 0. So that means my factor is x minus 4. All right, so now I'm going to use synthetic division to break down my polynomial. All right, so I have to use 1, negative 6, 14, and negative 24. All right, so I have 1, 4, negative 2, negative 8, 6, 24. My remainder is 0. So this is my remainder, constant x squared. Okay, so hold on. I'm running out of room here. All right, so let's see what we have so far. Here's my polynomial. 0 equals, we had x minus 4 as a factor, x plus 3 is a factor, and now we have x squared minus 2x plus 6 equals, and then we have equals 0. I already have it on the other side. All right, so make your t-chart here. All right, so I have x equals 4 is a 0, x equals negative 3 is a 0. This is my linear factor, x minus 4, plus 4, sorry, x plus 3. All right, so now I have to work on this. X squared minus 2x, I'm going to complete the square equals negative 6. So I have x squared minus 2x plus 1 equals negative 6 plus 1. So I did half of negative 2 is 1, squared is 1. So then I get x minus 1 squared equals negative 5. Square root both sides. So I get x minus 1 equals plus minus the square root of negative 5, which is plus minus I the square root of 5. Add the 1 over. 1 plus minus I the square root of 5. So let me just rewrite this here. So I have x equals 4, x equals negative 3, x equals 1 plus I the square root of 5, x equals 1 minus I the square root of 5. Those are my zeros. Now my linear factors are x minus 4, x plus 3, x minus 1 minus I the square root of 5, and x minus 1 plus I the square root of 5. Those are all my linear factors. All right, next. Thank God I only gave you one of those, right? Okay, so number 11, we're simplifying. We are multiplying the two rational expressions here. So remember, first you want to factor and then reduce. So in the numerator, there is a GCF. The GCF is 10x squared times 1 minus x. In the denominator, I'm going to factor the denominator. So I get x minus 9x plus 6 times. In the numerator is dots, x plus 6, x minus 6. And in the denominator, GCF is 5x times x minus 1. All right, so now I'm ready to reduce. 10 and 5 reduce to 1 and 2. X and x squared reduce to x and 1. 1 minus x minus 1 reduced to negative 1. X plus 6 and x plus 6 reduced to 1 and 1. And then I have this x minus 6, but it doesn't reduce with anything. So I have 2x times negative 1 times x minus 6. So that's negative 2x times x minus 6 over, and then in the denominator, just have an x minus 9. All right, and then let's take a look at B. All right, B is the division. So I'm going to flip it as I write it so I don't have to keep rewriting. So I have x squared plus 9 plus 20 over 7x to the third minus 56x squared. Remember, I'm flipping right now. I'm changing the multiplication, division to multiply, and I'm flipping my fraction. So x squared minus 3x minus 40. And then in the denominator would be x squared plus 10x plus 25. All right, now we're ready to factor. All right, this numerator here factors and becomes x plus 5 and x minus 5. X minus 4, sorry. X plus 5, x plus 4, sorry. All right, and then in the denominator, there is a GCF. GCF is 7x squared. And then we get x minus 8 times the numerator over on the right side factors and becomes x minus 8, x plus 5. And in the denominator, we get x plus 5, x plus 5. All right, so let's reduce here. So x plus 5 and x plus 5 reduce to 1 and 1. X plus 4 does not reduce with anything. X minus 8 and x minus 8 reduce to 1 and 1. X plus 5 reduce to 1 and 1. In the numerator, I have x plus 4, and in the denominator, 7x squared. Okay, so let's take a look at the last problem. So the last one says to find the slant asymptote. So remember, the slant asymptote, you could do synthetic division, you could do long division. So you're looking for the quotient without the remainder. So I'm just going to do synthetic division. It's just so much easier. And actually for B, we can't use synthetic. We're going to do long because of the 6 in front of the x in the denominator. All right, so this is what we have. We have f of x equals 6x squared plus 7x plus 4 over x plus 1. All right, so I'm going to put the negative 1 on the outside, right, because that's my 0, right? X is equal to negative 1. 6, 7, 4. So I get 6, negative 6, 1, negative 1, we get 3. So this is my remainder, constant x. So my slant asymptote is 6x, y equals, 6x plus 1. No remainder when we do slants, just this part here. All right, and then let's do B. Now, B, we have to actually do long division because I don't have a nice binomial. I don't have a leading coefficient of a 1 in the denominator. All right, so I have to do the long division for 54x squared minus 15x minus 19 divided by 6x plus 3. All right, so 6x plus 3. We're doing long division here. 54x squared minus 15x minus 19. All right, so 6x times 9x gives me 54x squared. And 9x times 3 is 27x. Right, parentheses minus. So this becomes a plus, minus, minus here. That cancels. So I get negative 42x. Bring down the minus 19. 6x times negative 7 gives me negative 42x. So I get negative 42x minus 21. Parentheses minus. Plus, 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 cancels, and then I get positive 2. Now remember, I don't care about the remainder. I only care about this guy here. So my slant asymptote is y equals 9x minus 7. Okay, so that's it. I know this is a long video, so it was a lot to go over. All right, but I will see you guys tomorrow. Good luck studying.